Welcome everyone. In this video lecture, we will think about a very fundamental relationship between the voltage amplifier and transconductance amplifier. In MOSFET AC voltage gain, we have saw this expression, the voltage gain AV equals to GM times of R naught, AV equals to GM R naught. So this is the relationship, means voltage amplifier gain equals to transconductance amplifier gain into the output resistance. So that we will verify through the equivalent circuit model of a voltage amplifier and transconductance amplifier. I have already drawn the voltage amplifier equivalent circuit and the transconductance amplifier circuits. So through these two diagrams, we will come to the conclusion that the voltage amplifier gain is equal to the transconductance amplifier gain. Okay, that is our GM into the output resistance. How it come, we will discuss. So the very first thing here in the voltage amplifier in the left hand side, it is very clear that a simple amplifier, a voltage amplifier, okay, voltage amplifier. So the gain, voltage amplifier gain, that is our, we can say AV can be written as V naught by Vi. We all know about this, means the voltage gain. Okay, so what exactly I am saying, if we have some amplifier, okay, so the voltage gain, okay, some gain, this one is amplifier gain. So gain will be, input will be Vi and output will be V naught. Okay, so this one is the amplifier gain. On the other side, what I am saying, in our, we can say in our transconductance amplifier, okay, in case of our transconductance amplifier, as we know, the formula IC equals to GM times of VB in AC equivalent model of a BJT, IC equals to GM VB, or the transconductance is nothing but simply current divided by voltage, IC by VT. So here we can easily say the transconductance gain, okay, or simply we can say GM here, or if we write here AV, V naught by VI, and GM is nothing but simply input should be our voltage. So simply we can say voltage and output will be the current output. So we can write it I naught. Okay. So GM is IC upon VT. Okay. So here the conductance, conductance. Okay. A transconductance gain, we can say the GM term is nothing but simply I naught by Vi. I naught equals to GMVB. So if we know this formula, we can easily say the voltage amplifier. The voltage amplifier gain is simply our, I'm just highlighting, voltage amplifier gain V naught by Vi and transconductance amplifier gain GM by Vi. So we can easily remember the formula by this formula GM IC, or transconductance current by voltage. So I naught is the output, here is the input. So this one is the equivalent model. So in this equivalent model, there is a, this one is the Vi input voltage, okay. And if you say some current is flowing, say this current is our II, and this current is going out, so say I naught. Here also we can write II, and some current is flowing I naught. Okay, so now from the voltage amplifier diagram, okay, so voltage amplifier diagram, the open circuit, I am writing here one line, open circuit voltage, okay, open circuit voltage, that is our, this voltage, okay, I am saying this one is open circuit voltage by keeping I naught equals to 0. Open circuit output voltage. Better to write open circuit output voltage. So this open circuit output voltage V naught is simply we can write A V naught into Vi. Okay. So this V naught is open circuit output voltage. V naught open circuit output voltage is nothing but simply A V naught into Vi by keeping I naught 0. So when I naught is 0, this voltage will be same as that of this AV naught Vi. So mainly during the voltage amplifier, the output impedance will be low, okay, or ideally we can say 0, and input impedance will be infinite, okay. So if I am saying one resistance is, for example, Rs is there, so this voltage we need same as that of Vi, or say this is a Vs. If I am saying this as a Vs, so Vs is same as that of Vi. So Vi is that equals simply Ri times of Vs by Rs plus Ri. Rs plus Ri. So if this Ri is infinity, this one is Ri. Okay, so if Ri is infinity, so this value will be same as that of Vs. So that's why Ri will be infinity. Okay or not? Once again, means this Vi is simply Ri times of Vs by Ri plus source resistance. Okay. So now we have to make this equivalent. So if I am saying Ri tends to infinity, Ri value is very high. Okay. So if we take Ri common, 1 plus Rs by Ri, this Ri can say Ri very high infinity around. So it should be 0. So this one will be Vs. Okay. So that's why this is very important relationship also. Means for a amplifier, this input impedance is very high. Input impedance Ri infinity R naught. Okay, for that we have solved. Yeah. Okay, so we can remove this. Okay. Okay, make a line here. Okay, so now this one is clear. So this one is also one important relationship, that V naught equals to AV naught into Vi, where AV naught is the open circuit voltage gain, okay, and V naught is the open circuit output voltage. Now from here, now from this diagram, okay, now from this diagram, what I am saying, if we have to find this voltage V naught, open circuit voltage in this side, so this V naught open circuit voltage, V naught is nothing but simply GMVI into R naught. V naught equals to GM, this voltage Norton equivalent, GMVI into simply R naught. So the open circuit output voltage, this one is also open circuit output voltage in a transconductance amplifier. This one is our open circuit output voltage in a transconductance amplifier is simply GMVI, this current into R naught. Okay, GMVI into R naught. So this one is the equivalent diagram. So we can easily write. So now these two GM, say this equation, say equation number 1, and I am saying equation number 2. Both, if we equate both the voltages, what we can write here, I am writing AV naught Vi equals to Gm times Vi into the output resistance. So this Vi and this Vi cancel out. So AV naught equals to Gm times of R naught. So this one is the relationship, that the voltage amplifier, that open circuit voltage gain is transconductance. Okay, this is a Gm into R naught. So that's why in any MOSFET circuitry, okay, okay, so this AV equals to minus Gm times of R naught. We have saw so many times. So this one is the thing that the voltage gain, open circuit voltage gain, is just a multiplication of the transconductance Gm into R naught. Okay, and Gm is simply the I output by V in. Gm is I output by V in or Vi, anything we can add. So this one is the all about this very simple concept that the open circuit voltage gain is nothing but simply the short circuit current gain. We can say the short circuit transconductance amplifier. Means here I am on this one is a open circuit voltage gain, and this Gm is our short circuit transconductance gain. In this case, open circuit voltage gain I naught equals to 0. In this short circuit, this case, the output value will be 0. V naught equals to 0 means for the transconductance, for this Gm, if some, if we make like this, plus minus Vi, and we have to make this as a short, and if some I output, so this Gm equals to I output by V in. This one is V in by keeping V naught 0. Okay, so this one is the fundamental. Gm equals to I output by V in by sorting this one, short circuit. Okay, so this one is the very important relationship. So now I think it is clear. AB naught equals to GM R naught. So this is all about this simple video about the relationship between voltage amplifier, means AB equals to GM times of output resistance. Okay, so thank you for watching this video.